Okay,
All right. So how are you?
I'm great. And you?
You're good. Very good. Very good. Thank you. All right. So for you, so what I learned last time was that you're into like competitive programming, and I feel like what would be good for you is algorithm design and how to think systematically.
Okay, so that
All
is
right.
what are we gonna do now? Like
Yes.
today?
If you don't have any requests for anything else,
Yeah, I don't
yeah.
have anything.
Okay. So all right. So I'm gonna introduce a something, and it's gonna be too easy for you, but that's the reason why I want to introduce something. Maybe hold on. Let me grab something.
Okay.
I'm grabbing out. Sorry, I've not done this yet, so this is new. But I'm taking out my drawing tablet because I'm gonna draw something for you.
Okay, that's quite interesting.
Give me 1 second to set this up. Ah, okay. You know what? It's gonna take me a while to set it up. I need to find the wires, and I don't have it on hand. Yeah, I'm just gonna. It's okay. I'll just use my mouse. Okay, give me 1 second as I set this up.
Yeah, no
Let's
problem.
draw. Okay, share my screen. Let me know once you can see my screen.
Yeah, I can see it now.
Okay. So I'm going to use my mouse to draw. It's going to look like crap, but as long as you understand it. So I'm going to draw a table, okay? This
Okay.
table, there's two axes, okay?
Yeah.
One axis is called systematic steps. So like you like step one, you do this. Step two, you do this, and so on, okay?
Okay.
In total, there's about 8 steps, okay?
Yeah.
When I say systematic design, like here's a problem, how do you get the solution? You're going to follow these 8 steps, okay?
Okay.
All right. So that's one axis. The other axis is I'm going to call it the complexity of data. For example, atomic data like number strings and booleans. This is like easiest.
Mm-hmm.
Then
Okay.
you have something very complicated like graphs. Okay,
Okay.
this is the one of the most complicated. Like in fact, yeah, it's the most complex data definition. Okay,
Okay.
okay. Now I'm going to pick your brain. What are some things in the middle here?
Like an array.
So okay, if yes, but I'm going to call it a list for now. The
Okay.
idea that you have a chain of things
Yeah.
that are arranged linearly. Yeah.
Yeah, okay.
Some other shapes, other objects, mathematical objects in here?
Hmm. Mathematical objects
Yes.
like squares or something. I don't know.
No, no, like sorry, computer science objects. Like
Okay, so
in your
like
competitive
trees,
programming, what are some
like
structures you work
like
with?
trees.
Trees, yes.
Yeah. Okay.
Trees, if you think about, they're like lists, except they have multiple
Yeah.
children, right?
Okay.
Okay.
That makes sense.
Do you know any other objects?
Uh, I don't think so.
Okay.
I
So
haven't learned it yet.
in competitive programming, you actually only need to know these four,
Okay.
basically. However, in programming, there's actually something here and there's something here that you probably won't use in competitive programming, but it's good to know. Okay?
Okay.
And my goal for you for now, in these sessions, I want to work with you on how to think systematically for each type of data. So each data
Okay.
have their own steps. They're basically the same, but as you get into more complicated structures, so like graphs, the steps are a little bit different. Okay? There are more ideas. So that's my goal
Yeah.
now. In and by the way, I can't teach you this in like 2 days, right? This will take time. I don't know how long. It depends on you. It depends whether or not like yeah, every student is different. I'm not sure how long this is gonna take, but I think you'll benefit a lot from this.
Okay.
Now, there's actually these are like what I call the basics. I call these like fundamentals one. There's actually more after this. More is like data structures, like like DEC.
Deck.
You know what this is,
Yeah, yeah. Okay.
right?
Like it's first in, last out, I think. No?
It's actually both ways. Yeah,
Okay, yeah, okay, okay, it's
yeah,
both
yeah,
ways. Like a
yeah, yeah, yeah. So
queue
like
is
these are
okay.
data structures, right?
Yeah, yeah.
So
I know
all
like
these.
the standard ones in C++. plus plus.
Okay, so that's good. So all these are like atoms. All
Okay.
this gives rise to bigger ideas like DEX,
Mm,
like data structures. And then, well, in your case, you can stop here. You can stop at data structures. But then when you write full programs, you can like create like full mechanisms. That this is me drawing a gear, but I'm on a mouse right now, so I can draw. Okay, I'm gonna stop. Okay, so my goal for you is I start with the simple, start with this table, and then I'll if we have if like we are still doing this and you're progressing very quickly, you can move on to data structures.
okay.
The A lot of big algorithms exist here, but we need to build up there. We need to first go through this table first. Okay.
Mm,
All
yeah,
right. So this is me giving you a map. This is our roadmap for the near future. Okay. All right. So I'm going to start this very, very simple. I'm going to start us off in this table. I'm going to show you things that are like, you're going to think to yourself, this is beneath me. But the reason why I want to start us off simple, I'm going to clean things up a little bit. The reason why I want to start us off like on this side of the table is because I want to introduce you to these steps. This is new to you. Okay?
yeah,
These steps are new to you. Like, this isn't new to you. You probably know this, you probably know this, you know this, and you know this. But what does this mean in the context of steps? That's new to you. All right?
yeah. I don't know any of this
So
like
yeah,
steps.
I'm gonna start us here, okay? And this is gonna be too easy for you. I know it's gonna be too easy for you, but I want you to humor me because I want you to get familiarized with what are the steps. And once you're good
Okay,
with this,
okay,
we'll climb the table. We'll slowly upgrade to the right. Okay?
okay.
Okay. Now do you use Visual Studio Code, right?
Uh, can you say that again?
You use Visual Studio Code, right?
Yes, yes.
Okay, so I'm gonna use Visual Studio Code. I don't always do this with everyone, but usually someone that is a bit more experienced, I use Visual Studio Code because I want to use live share. Have you used live share?
I don't think so, but I heard that people use it in VS
Okay.
Code.
Okay,
Is it
great, great.
an extension or
Yeah, it is. Can you go to Visual Studio Code and install an extension
yeah?
now? Okay. I'm going to,
Live share, yeah?
yes.
Okay.
Just install an extension. Once you install the
Yeah,
extension, I'm going to send you a link on Zoom chat. I want you to click on that link. That's an invitation for you to join my session.
okay.
I'm going to share my screen. You don't have to look at my screen, but it's for people on YouTube to watch.
Yeah, of course. Okay. Uh, oh wait. Okay, I have it in my Visual Studio Code.
Great. Next, check the Zoom chat and click the link.
Yeah, I have clicked the link. Yeah.
Okay, great. All right, I see you. Next, can you go to extensions and I want you to type in pirate, that's Pyret.
Yeah.
Do you see a skull with three bones?
Yeah, I have
Okay,
installed it.
okay, great. Can you go to the file sunset.arr?
Yeah,
You
I
see the
have.
file? You can see
Yeah,
hi.
I
Can you
can.
see this? You see that line?
Yes, yes.
Great. Okay. Do you see at the top there's like a white bar and there's a blue run button?
Yes, yeah.
Okay. I'm gonna put the number five. I'm gonna run it. Can you see five?
Yes.
Okay, good. We're
Uh,
set up. Okay, this was very efficient. Great, great. So let me explain what's happening. I'm gonna start this in a language called Pirate. It's designed for beginners. Uh,
Okay.
to me, right, when at a certain point in programming, all these languages look the same. A lot of the principles I'll teach you here can be transferred to C++. But the reason why I want to start us in this language is because it provides some facility that C++ doesn't easily provide.
Okay.
So it gets us to where I want to go quicker without the boilerplate stuff, basically.
Yeah, okay.
Okay, I'm
That
gonna
makes
go
sense.
very quick. If it's too fast, let me know. If it's too slow, also let me know. I will adjust the pace,
Okay.
okay? So I'm gonna start us with the easiest, which is atomic data. This is data that cannot be broken down any further. In this language, I'll show you three. First is numbers, like three. So there's numbers. You have like three. You have decimals also. You have imaginary and you have like exponents, but I don't know how to
Yeah.
write those. I think so. I think it's this. Let me try writing it. Yeah. So the third one is a standard notation if you're familiar with science.
Yes, I know that, but
Then there's
I must assure you that I can't see the code that you are running. I must run it myself.
yes, yes, yeah. Sorry, I forgot to mention
Okay.
that. Um, I forgot how to write imaginary. There is
Like
imaginary,
in
but
Python, it's J,
I
not I don't know.
yeah, it's not J either. I don't. Okay, it's okay. Not important for us because you do competitive program. Do you use
Yeah,
imaginary numbers in competitive programming?
I don't think so.
Yeah, I don't think so either. Okay. Okay, anyway, so we have numbers. You have okay. Strings arguably isn't atomic because you can break it down to characters, but let's just say it is for now. Like hello.
Okay,
A string can be empty. You can use single quotes or double quotes, either is fine.
okay.
Also, you might see, do you see a red CR on your screen?
Yeah,
Oh, ignore it. Pretend that it's not there.
okay,
It's a carriage return on Windows. When I hit enter, it puts in a key called carriage return.
okay.
Just ignore it. Yeah, pretend it's not there. Okay, so your strings.
Are you using
Next,
Linux?
I use Linux also, but currently I'm on Windows.
Okay,
Finally, we have booleans, true or false. Okay.
yeah,
All right. Something to know in this language is that when you use an operator, symbolic operator like plus, you need to have a space. If I remove a space like this, it will error saying you need a space.
oh,
This is a quirk with this language. I'm just letting you know now. Everything else is the same, like functions. Like there's a function called num_min that gives you the minimum of two numbers. It's pretty
okay,
standard notation. But to define a function, let's say f, it looks a bit different. Let's say I have a number, I call a function f of x that adds 1 to x. It looks like this. It's
okay,
uh it's like Python, but instead of def, you write fun, and you need to write end at the end.
yeah,
Why is
okay,
it like
okay,
this? It's because this language is designed to transition you to Python. Where in Python, they use indentation to specify the body of a function.
okay.
But
Does in the indentation here doesn't matter?
doesn't matter. So I can do this also, it
Okay,
will work.
okay,
But how do you know it's the end of the function? Well, there's n.
okay,
So in C++, you have the brace, curly brace, but here you have n. It's to make it look like Python basically, without making it Python. Okay?
yeah, okay,
So these are just the mechanics of the language. I'm not really showing you the programming step yet. Now I want to introduce you the design. Okay, the table I showed you just now, one axis is steps, one axis is complexity of data. We call this the design recipe, essentially. Design recipe. The idea of
okay,
design is that go from A to B systematically. All right? The idea of a recipe is that follow the steps. Okay?
yeah,
It's like when you're cooking, you follow a recipe, you follow the steps. Okay?
yeah. So it's like a definition of algorithm.
Yes, basically. It's a bit
Okay,
okay. We are gonna get there. It sounds weird. You may not when I'm going to give you the design recipe now, you're not going to believe me or help you with algorithms, but trust me, it will, okay? You just have to trust me.
okay,
So, a design recipe, there's two versions. I'll show you one version. There are 8 steps. There are 4 steps for designing data definitions, and there are 4 steps for designing functions. Okay?
okay,
So, what are data definitions? Data definitions. Remember how I say there are two worlds. I don't know if I told you this. There are two worlds. There's information and data. Did I tell you this last time?
No, you didn't tell me
Okay.
this.
So it's a very philosophical idea. There are two worlds. There's information and data. Information is ideas about real world, basically. For example, 5 degrees Celsius. Data, what the computer sees. Okay? For example, I'm going to write this 5. What does 5 mean? Let's run it. You see 5, right?
Yeah,
What does 5 mean?
like nothing really.
Nothing. It's just 5, right? But what if I say
Yeah,
5 degrees Celsius?
La so it means that is 5 degrees Celsius.
Okay, what does
Like,
Celsius mean? When I say when someone in real life talks says, "Oh, it's 5 degrees
like
Celsius right now."
you are talking about like temperature or
Temperature, right?
something.
Okay.
Yeah,
How about 5 kilograms?
like weight.
Weight, right? Okay, so depending on the unit of measurement, it means something different, right? It means more.
Yeah, okay.
Okay. So there are two worlds. There's information, so 5 degrees Celsius is information, and there's data. Like the number 5 in front of us, that's what the computer sees. The computer does not know its temperature. Okay?
Yeah,
Like, like in competitive programming, there's a context in the problem. Like last time we did cows, but when you
yeah.
wrote the code, there's no cows. It's just numbers, right?
Mm,
It's just data. The idea of cows is for the human, but the number is just works with, sorry, the computer just works with numbers, doesn't know about cows or whatever, right?
yeah, okay,
Okay. So this is a key idea, which is data definition. A data definition defines data. It defines how the computer understands. So data definition defines what the computer understands. So this is data and what that means to a human. We call this interpretation, how we
mhm,
interpret data, okay?
okay,
So the first two steps of the design recipe for functions is what is how does the okay, no, data representation, how does the computer understand it? So that's step one. You must choose the data representation. Step two, interpretation. How does the human understand this? Okay.
okay.
So I'm going to give you a very, very simple example now. Now, this is too easy for you, and I know you think it's beneath you, but humor me, okay? Let's
Yeah,
say
okay. I
we
trust
have,
you.
trust me, yeah, trust me. We have information that's 5, like Celsius, like temperature. We have information. We want to have the idea of temperature in our program. We want it to understand temperature, okay? First thing you must write the data representation. Temperature is a number. So I choose to represent temperature as a number, okay?
Okay,
Next, I must write the interpretation. Uh, represents how hot or cold it is. Let's just say, okay?
mm-hmm,
So these are the first two steps. Step one, what is the data representation? So line 17, we say it's the data representation. We represent temperature as a number. Step two, interpretation. Okay, to a human being, what does that mean? Sometimes you can skip step two if it's too obvious, but since we're learning, let's not skip any steps. Step
okay,
three, examples. Examples, so in this language to write variables, you use equal sign. So like for example, 5 degrees Celsius, I can say is 5. So
okay,
maybe I can do negative, right? Negative 5. Let's not do 5. Let's do a different number like 4. Example, like right now I'm creating examples of my data definition, so negative 4. And I try to mix it up, like 0, for example. 0 is a good example. So here we think about edge examples, like examples that are very interesting, like 0, right? 0 is a very interesting property because it's neither positive or negative.
yeah,
Negative is interesting because it's negative, right? Next, maybe decimals, right? Decimals is also interesting. So maybe like 3.5. Okay.
yeah,
So
okay,
yeah. So remember when we did the cows problem, we were going through examples.
Yeah.
So for more complex data, for more complex problems, this step will be more interesting. But for now, it's very simple. Because again, I'm just trying to show you the steps.
Okay. Okay.
Step four, I'll show you later. There's a fourth step, but we're going to skip that for now.
Okay.
This fourth, I'm going to tell you right now, is very important. Like, if I ask you right now, what do you think the fourth step? Okay, let me ask you, what's the fourth step? Do you know what it is?
Like writing the actual code?
No. Dude, that's
No?
like the final step, bro. That's so far away. We're not even there yet, man. Okay.
Okay.
So yeah,
So
this is a very powerful idea, and we'll get to that. So this is data definitions minus one step. Now let's go on to functions. So let's say we have a task. So the task I'm going to write for you now is create a function that converts Celsius to Fahrenheit. Okay? Very,
yeah,
very standard.
yeah,
Now, one important thing is in the data definition on line 20, do we say that this temperature has a unit of measurement? Do we say is it Celsius, is it Kelvin, is it Fahrenheit? Do we specify it? Okay?
okay,
So f- you can argue either or. You can say let's specify it, let's not. It's really up to you as a programmer. Do you want to specify it? I am going to say, I'm going to be more specific and call this Celsius.
okay.
Actually, do I want to do it? Okay, I'm going to do it. I'm going to do it. Uh, and this means I need another one of Fahrenheit. I think this is overkill. I wouldn't do this in a normal program, but since we're learning, I'm just going to do this. Okay, so I'm going to create a function that converts Celsius to Fahrenheit. What is a, okay, let me ask you, what is a function?
Uh, how to say it in English? A function is something that we write if we have like a code that needs to be executed several times.
Hmm, okay, that's a good answer. Um, I'm going to get back to your answer in the future. Let's table it, but I'm going to give you a different explanation for a function. A
Okay,
function is quite simply something that takes inputs into outputs. Okay? Give it
okay,
something and it gives you something back. Okay? That's a function. All right? So a function goes from input to output. Okay?
yeah,
Um, so what is the input in programming? We say the input is the parameters, right?
yeah,
So a function has a body. A body is what produces the output. Okay?
okay,
Another vocabulary is signature. This is the data representation for what for input and output. Okay, this sounds abstract. Let's jump into an example. So I'm going to create a function that converts Celsius to Fahrenheit. The first thing I want to do, so the first step of the design recipe is write the signature of the function. The second step, write the purpose statement of the function. So what is the signature? So my function is going to take in Celsius, and it's going to come out, it's going to produce Fahrenheit. Okay?
okay,
Notice how I'm using the data representation I defined. Celsius and Fahrenheit, that is something I defined just now. Okay?
yeah,
So I'm using that. Arrow is, so this is my syntax. I can put like, I can do this, I can do this, but I'm going to keep it simple. I'm just going to do this. This is
yeah,
my
okay,
convention. Okay? So this is the signature. Next is purpose statement. What does this function do? So I would say converts temperature in Celsius to Fahrenheit. Okay? So
yeah,
first two steps. Next, I write, this is like a secret step. I'm going to call this secret, right? The stub. I don't consider this part of the, I consider this part of, yeah, you know, I don't want to say, I consider this to be part of the first two steps, right? The stub. What is the stub? A stub is a function without a body. So I write the name. So it's a cell, I'm going to call this Celsius to Fahrenheit. Next, I take in the input. I'm going to call the parameter C, and then I leave this body empty. So I write dot dot dot, and then I write n. So a stub is just a function without the body. So I'm going to write that.
Okay.
Yeah. So that's the secret step. Um, Next, you write example slash tests. So in this language, and this is why I wanted to use this language and not C++. C++, you have to import a library or something. Here, testing is part of the language. To test in this language, you write where, and then um, you can write your test cases. How do you write tests? First, you call. Oh, let me ask you, what is a test?
Test.
Yeah, what is a
Oh.
test?
Uh, that is a hard question. Uh, Test is like an ex like uh, it's easier for me to say that we use tests to see if our code is correct,
Okay.
but
Yeah.
yeah,
You're giving me a property of test, right? You're saying, oh,
okay,
it lets us do this. But let me tell you what a test is, at least in programming. A test, you just check are two values the same? If they are, the test pass, otherwise the test fails.
okay.
So for example, what is Celsius to Fahrenheit at 0? Do you know the answer to this?
Mm, like is it 32 or something?
Yes, it's 32,
Yeah,
yeah. Okay. Um, so okay. Um, uh, wait, this we call this a check, actually. We say a check. Check if Celsius to Fahrenheit 0 is 32. That's what a check just checks if it's a check. It checks, right? Check if it's true. Yeah.
okay.
Um, let's try a different example. There's there's one value that is like the same for both Celsius and Fahrenheit. Do you know? I forgot.
Uh,
It's the same as I'm Googling right now.
oh, okay,
I think it's negative 40. Negative 40. Yeah, okay. So I'm going to do this.
okay.
So sometimes functions have mathematical properties. So Celsius to Fahrenheit is we say it's fixed point. No, no, that's not a correct term. We say it's the identity at negative 40. I think I'm mixing up my math terms, but it gives back the same thing at negative 40 only. Okay?
Okay.
Yeah. Notice how sometimes I use the defined examples, whereas other times I use raw numbers.
Okay.
Um, it depends. Sometimes I'll use the defined examples, and sometimes I use raw numbers, whichever is handier. Sometimes I'll take the raw numbers and turn them into examples. Generally,
Okay.
you should always use examples, like declare a constant. Why? What happens if you change the data representation? Now we use number, but what happens if we change it to string in the future or something, right?
Okay.
If you change that data representation, you only have to change the examples. Whereas if I use raw numbers here in my tests, I have to
Yeah,
change
you
the
have to
examples
change
and the
everything.
tests.
Yeah.
Yeah, but this is more like a concern for programmer. Like if you're building like industry software, but in your case, you don't really need to care about that. I'm just letting you know for your knowledge.
Okay.
So our goal when writing tests is you want to do two things. First, just like you said, it checks for correctness, right? That's
Yeah.
actually wrong.
Okay.
Okay, this is like a math thing I'm about to tell you. You can never know if a program is correct. Well, you can, but not with tests. Test doesn't tell you if a program is correct. Because what happens if there's one thing you didn't think of, there is a test that will fail. You just haven't thought about it, right?
Yeah.
So when we talk about correctness, we're saying we're proving correctness. We're proving a program is correct. You can't do that with tests. You need logic. So there are programming languages that have logic built into them that checks if a program is correct. So like languages like Lean, COQ. I don't know if you want, yeah, these are quite esoteric. You might not have heard of them.
Yeah,
But
I'm not familiar with
yeah,
this.
so mathematicians sometimes use like mathematical programming languages that check the correctness of programs.
Okay.
It's used in like cybersecurity research, operating systems research, when like correctness is like very important. But for testing, it doesn't check if it's correct. What it does is it builds confidence. If you have
Okay.
100 tests and all of them pass, you feel very good about yourself, is your program is likely correct, right?
Yeah.
Okay, so here I want to add more examples. So maybe like 3.5. So the right-hand side doesn't have to be a raw number. Sometimes it can be a calculation. Let me see. What's the formula for Fahrenheit to Celsius?
Uh,
It's
it's Celsius times 9/5 plus 32.
okay, thank you, thank you. So
Yeah.
Celsius
I'm surprised I
times
remember that.
9/5 plus 32, sorry, plus
Plus
32.
32, yeah.
Okay. So very oh yeah, this I think this language has fractions as well. If you notice 9/5 is purple. Forgot to mention that. Not all languages have
Yeah.
this. I don't think C++ has this.
No.
Yeah. So notice like my right hand side is not a single number, it's like a computation. You can do that as well.
What?
The right hand side of the check, like the is something. Notice the something is not a number. It's a
Uh,
calculation.
yes, yes. Okay.
It's a
Okay.
whole expression, right? Like 3.5 times 9/5 plus 32. I just wrote the whole thing out.
Yeah.
Yeah. So a check doesn't have to be just numbers. Sometimes you can do this. It's fine. For programmers, a cost about doing this is that if you're running something that's very expensive, your test might take a long time to run, but we don't have to worry about that.
Okay.
Okay. Now, the last step of the designing function, this is what you talked about. Actually, fill in the body. So notice how I skipped the fourth step of the data definition, but that's okay. We'll come back to that in the future. So now you fill in the body. So what we have been doing so far is we're sort of like, imagine the problem is someone we're trying to kill. We're trying to shoot the problem. We're like filling in our ammunition. We're gathering ammo to shoot the problem.
Okay.
Like this problem, you could probably solve it immediately without doing all these steps. But trust me, just follow the steps for harder problems will help you. So
Okay.
now I'll finally solve this. And the way I'll solve this is I'm just going to copy and paste one of my examples, and I'm going to generalize it. I'm going to turn this into a C, right? I turn the one thing that should change between examples, and I turn that into my parameter. Thus now
Okay.
I can run. I hit the blue run button. You should be able to see that all three tests in this block passed. Okay.
Okay. Yeah, I see it.
Okay. One thing I didn't specify. Uh, okay. Let me try something. I'm going to write. I'm going to do this. You don't have to know this, but I think it's good for you to know. Oh, it passed. Do you know what I'm trying to do?
Uh, yeah, I think so. Like, does this language like in JavaScript, like when we have decimal points, it's not like as accurate as
Yes.
it seems. Yeah.
Okay,
Okay.
so this is
Like,
called floating point imprecision.
yeah. Okay.
Sometimes two floating point. So what is floating point? Notice how I say like a 5.2, that's a point.
Okay.
Remember, like computers are just zeros and ones, right?
Yeah. Yeah. I know it. We learned
Like,
it in
okay, so
like class.
the idea of floating point is that you have a there's a data representation for numbers. So to us, this is just a number, but for the programming language, it represents this as a bunch of numbers. There are, like scientific notation, like that's the 10 times,
Yeah. Yeah.
like 5 times 10 to the
Yes.
power of 3. So there are like three parts, right? Uh, Okay. So we basically
Yeah.
have these three parts, but to represent decimal fractions, but it's inaccurate. One of these numbers, I forgot which one, I think it's the middle one, is used to determine where the point is. That's why it's called floating point. The point floats. but this is
Mm,
imprecise.
okay.
So to check if two floating point values are the same, we shouldn't use is actually. We actually should use is approximately.
Like,
Or
okay.
is it approximately is?
Does it use like epsilon or something?
So in this language, there's a shortcut, but in like C++, yes, you should have a epsilon.
Okay.
Your threshold in which it's close enough. Okay, you don't really need to know this, but it's very good to know. Like imagine you're like writing like software for like spacecraft. If your thing is off by 0.0001, that might be enough to crash the spacecraft, right?
Yeah.
So it's important to be aware of these things. Okay, anyway, I'm gonna leave it as is for now because it's not my goal. Okay. Any questions on the design recipe?
No, I don't think so.
Okay. We are now going to upgrade. So we were on the left, remember the table? We were on the leftmost side, we're on the simplest, we're on the atomic data definition. We're gonna move on. Um,
Okay.
okay, so far I know you haven't been programmed. Like my goal is always to get a person programming, but I'm just trying to like get you up to speed as fast as possible. That's why I've been typing for you. I'm
Okay.
gonna create a new file for you. So actually, no, I'm gonna keep this file, but I might create a new file at some point. I'm now going to move on to a different data definition, a data representation. I'm going to go to enums. Are you familiar with enums?
Yes.
So I'm going to go to line, let's say line 30. I'm going to create a new data. Okay, let's say we have a situation. Let's say we have a traffic light system.
Mm-hmm.
Traffic lights red, green, or blue, right? So this is a real world example, actually. Like the traffic lights are computers, there are computers in them. And there's a representation for red, green, and blue. So I'm going to write this down. A traffic light is one of. And I need to represent. How do I represent red, green, and blue? Shit, why did I say blue? Sorry, yellow. Red, yellow, and green. Japan is blue, I think.
Really?
So
I didn't know that.
yeah. Some countries have different colors. Okay, so red, yellow, green. Notice how I'm using strings to represent this information. So a key
Yeah.
difference between this one and the previous one is that we have one off. It's one of possible values. Okay.
Yeah.
Next we have the interpretation. Um, gives instructions for vehicles. Okay, yeah, this interpretation not very important, it's fine. So for examples for enums, there's a finite number of them. So I just do this. Now notice how line 38 and line 33 are the same, right? They mirror
Yeah.
each other. Okay. Um, so these are the examples. One thing you can also do is you can do this. You can integrate the examples with the data representation. It's a little, so this you can remove, you can have a single point of truth. You don't have red string specified in two places. Okay.
Okay.
Now, for problem solving, right, creating examples lets you think about the nature of the data. But in our case, for enums, the benefit of examples is it lets you define constants. What's the problem of writing the string red many times? What's the problem of doing this?
Like in code,
Yes. What's the problem of
uh,
using red string many times?
like if we wanted to change something, we must change it like several times.
Very good. So for example, what happens if you want to capitalize the red, right?
Yeah.
For example, but even worse, what happens if I make a typo, RDE? If I write RDE, it's so hard to see, and I'm not even kidding you, this will cause so many bugs in your program. It's so hard to find. But
Okay.
let's say I write red here, lah, RDE like this, and I hit run now, it'll be a problem because it doesn't know what RDE is, right?
Okay.
So you can get more help from the programming language. Okay?
Mm.
Okay. So this is the design recipe for.
Okay.
Okay. So yeah, so it prevents typos. Um, I'm gonna skip the fourth step for the data definition again, but I hope to introduce it at the end of this section of this session. Now I'm gonna go to functions. So I'll just write the function here. So let's say I have a task. Uh, rotate between the different traffic light states. Oh yeah, in programming, right? So this might seem like a very simple example, but in programming, we often actually do this. Maybe not with traffic lights, but in programming, there's a thing called finite state machine. Have you heard of it?
Uh, Maybe not in English.
Okay. So you have different states. Each state is like a node in a graph, and you are transitioning between where you are on the graph.
Okay.
Yeah, but you don't need to know this, but this is sometimes used to represent state machines, which is like this, like a traffic light, but generalized to more contexts.
Okay.
Yeah, yeah. So this is not like a contrived example. This is like something you can do. Anyway, so yeah, so let's say that's our task. Now we follow the steps for designing a function. So for example, just to be clear what this task is. So let's say it's red. If it's red, you go to green. If it's yellow, you go to uh red. If it's green, you go. Wait, no, no. Yellow is go to red. Yeah, 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 yeah. Okay, green is to yellow. Okay, familiar, right? I don't know if you drive, but
I don't.
okay, never mind. It's okay, but
Yeah.
it's okay. Just take my word for this.
Okay.
Uh, all right. Now I want you to help me write this function using the design recipe. Line
Okay.
45. Okay.
Uh, so first off, we need to like uh write a signature, uh, like a stub.
Okay. Let's do that.
C can I write?
Yes, yes,
Oh,
please.
okay. Okay,
Yeah.
sorry.
No, it's
Like
okay.
I didn't know that. Where do I write? What
Let's
line?
say line 45.
Line 45. Okay.
Yeah.
Mm, why? Awesome. Okay. Okay. So that is the first step.
That's actually the third step. That's the
The
stop.
the third step. Okay. S- s-
Signature. Do you remember what a signature is?
Like what that thing does.
No, that's purpose statement.
Okay. What was the signature?
It's a data representation. It's how the computer understands the inputs and outputs of this function. So what's the input of
Oh,
this function?
like a string, and output is also a string. Yeah.
Oh, is it any string?
No, it's one of the colors
Okay, it's
above.
one of the three strings, right? Red, yellow, green.
Yeah.
What do we call
Okay.
this data representation?
Like enum,
Or yeah, but like in our code base specifically, what do we call this? Red, yellow, or green?
like states, light states.
Yes, but these are the technical terms to describe it. But remember how when you define a data definition, you must give it a name? Like temperature, we called it Celsius. Remember that?
Okay, so colors.
Look at line 32. What do we call
Uh,
our data definition?
oh, like a traffic light.
Yes, traffic light.
Okay.
I know it's okay. I'll talk about this later, but it's very important if you reuse the same language, you reuse the same vocabulary. So traffic, we
Okay.
we say traffic light, we should use traffic light. All right,
Mm.
let's keep going.
So it's can I comment it like this? Okay.
Yeah, perfect. So that's step one. Nice. What's step two?
Yeah. Step two. Write the purpose statement of the function. Uh, Okay. Mm, so like it's like is that correct?
Yes, perfect. So that's step two, and now you've also done the stub, so that's good.
Yeah.
Okay, what's the next
Uh,
step?
so we are going to do test examples test now.
Great.
Now, where mm, can I copy that?
Yeah.
Oh, well, no.
Should we use the raw string?
Okay. If we have, sorry,
Yes, very
my
good.
bad.
No, all good, all good.
Yeah. What's green? Okay. Of it's uppercase. Okay.
Okay, what's
I
next?
think what's next? Uh, like writing the actual function. Hmm. Are the if statements here like
Mm. Let's just say it's same with Python.
okay?
Yeah. Oh, very good. You
Uh,
need to use an if. Why do you decide to use an if?
because we need to switch something.
Okay, good, good. Okay, keep going.
Okay.
Yeah.
Hmm. Like and the compare operator is
Mm.
double equals double.
Uh, I want you to use string if. Okay, okay, this one I'll give you one example. Okay, just because
Okay.
I want you to get one example. So let's do this. Wait. Yeah, yeah, that's correct. Also, it's actually just this. Oh my God. I have replace mode turned on. How do I do? Okay, sorry, give me 1 second. Okay,
Okay.
I've just given you one example now. Okay, can you fill in the rest?
Yeah. Uh, why is it nested? Do I need to like okay you put and okay sorry.
I'll tell you something else. You can also do this.
Okay.
Yeah.
So
So yeah, it's similar to C++. plus plus.
yeah I know that but
Okay.
mm, oh what? Okay, is that it?
Let's run it.
Uh,
Okay, I'll tell you the problem. Line 47, the UN should be FUN, like short for function. It's missing one letter.
yeah, For me, it's everyone.
What?
Yeah, I can show you my screen. It's everyone.
Okay, yeah, show me your screen. I don't believe you. One
Yeah.
of us is crazy.
Uh, okay.
What?
It's quite funny.
What?
Uh, I had it like this,
Okay, now
like all the time.
I'm gonna do this for you.
Okay.
Okay, there you go. I just
No,
fixed it.
nothing changes for me.
What? Really?
Yeah, yeah.
Okay, I think there's a bug with Visual Studio. Like for me, it was missing a key. Anyway, you made a typo in between. Wait, let me check the screen again. Maybe are we seeing something different? Oh no, no, no. Your screen is also there's a typo in the function name. Do you see it?
Uh, yeah, okay.
Yeah. This is why testing is important. Ah, would have thought
Ah,
that.
but something is wrong in
Wait, is it
string
not called string?
equals.
Oh wait, is that my mistake? Oh, I think that's my mistake. Hold on, let me check. I thought string equals.
Okay.
No S. Sorry. No S.
What?
No
String
S. It's
equal?
string equal. Yeah.
Okay. Equal. Okay.
Sorry. Okay, now it's correct. Okay. Do I want to? We don't have time for templates. Okay. I'll save that for next time. But I want to introduce one more idea before we go.
Okay.
So notice how this idea of one off, red, yellow, or green, we are the
Yeah.
ones enforcing it, not the language.
Okay.
Like the language, it doesn't have any idea what traffic light is. It's a comment in our code, right? This
Yeah.
is our ideas that our human brains are imposing on our program, and we're just making sure that we are following our own rules, right?
Okay.
We can actually let the language know what they are. There's a syntax for this. We call this data. So, um, what we're doing is we're creating a data representation, but the language also understands it.
Okay.
So first, I write data. Next, give me 1 second.
Yeah, no problem.
I'm also checking what the syntax is. That's why I'm doing it. All right. Next, we do this. I think call a bar, this straight line.
Okay.
That, yeah. Next, we type the word. So now I'm not using string anymore. I'm using it's like a string, but without the quotes.
Okay.
And then green, and then N. So here, wait a minute. I think it's still, okay, yeah, I'm just gonna delete the examples we wrote.
Okay.
And next, we change all instances of, oh my gosh. Okay, sorry. I'm changing our examples in a test to use the lowercase.
That's not, oh, it's not like in VS Code. Okay.
Okay, finally, I'm going to no longer use if or else if. I'm going to use a thing called cases.
Hmm. So like switch in Python or like in C++.
Yes,
Okay.
yes. What's my cases? Interesting. Sorry, I'm a little slow because I'm also not very familiar with the syntax.
Yeah, no
So,
problem.
yes, okay. If it's red, then it's green. If it's yellow, it becomes red. If it's green, it becomes yellow. And now I'm going to delete out if, else if. Um, Oh, sorry, the second I shouldn't be there. Okay, and it passed, right?
Yeah, okay.
So I want to talk about two things. The first thing I want to talk about, notice how we went from using strings to using a language feature that encoded this data representation. Do you see that?
Yeah,
Notice
yeah,
how we're getting more help from the language.
yeah,
So
okay,
languages, they give you the ability to create data representations like this one. But some languages don't let you do this. Some languages will require you to do what we did just now. Like just now, if we're on JavaScript, we have to do what we did just now. We have no choice. Okay?
okay,
So yeah, we got more help from the language basically, using a language feature designed for this purpose. The second thing I want you to notice is notice how we had to use a conditional. Now, we just now we used an if else if. Now we use cases, but they're both conditionals. What's
mm,
a conditional? If a conditional basically means we have to take one of many choices. So here we have many choices, red, yellow, or green. We use a language feature, now we use cases to determine red, yellow, or green. Okay?
okay,
Why do we have to use the conditional? Notice how there's a mirror between line 51 to 53 and line 34 to 36. You see
yeah,
that? We say they're parallel. How our function looks, it will be similar to how our data definition looks. Okay?
okay,
Our data definition is fundamentally about one of three choices. So our function is also fundamentally about choosing between one of the three choices. You see that?
yeah,
So in programming, we say that the shape of the function follows the shape of the data definition. Okay?
okay,
So remember I used the word shape just now. So like trees are a shape, graphs are a shape. So that means when you know your data definition is the tree, your function will look in a particular way. And that's why I'm showing you this. Okay?
okay,
There's more ideas I want to explore, but we are out of time. Uh, I'm save this file. You should be able to, but I'm also gonna send it to you. Okay.
okay.
All right. I
Can
have
I
to pause here.
stop share screen? Yeah,
Yes.
okay,
All right. I'll catch
yeah,
you next time. I hope you learned something today.
okay. Can I have one question?
Oh yes. Yeah.
You texted us that like there will be a additional lesson that we can
Oh
take.
yeah. So within 48 hours of a session, you can book one. Yeah.
Oh, okay. So like I can book one for like uh Thursday or something? No, no,
Thursday is too
Wednesday?
far. Yeah. Wednesday,
Wednesday?
yes. Tuesday, yes. But
Okay.
Thursday is too far. Yeah. It has to be within
Okay.
48 hours. Yeah.
Okay.
Okay. All
Thank
right.
you
I
so
hope to
much.
catch you again. I do have to run now, so I'll see you later. Bye bye.
Yeah, see you later. Bye.